All right. So I'm Erika Hamden. I'm a professor in Steward Observatory. And today I'm going to be briefly talking about my continued quest to win an Explorer mission from NASA. Do I just advance the slides? So this is as all of the things that I do, this is a multi-year odyssey for me. I submitted an Explorer mission to the Medium Explorer Astrophysics call in 2021 called Hyperion. I'd actually submitted it as a SMEX in 2019. That was the first Explorer proposal that I put in. I learned a lot. For the MidX, there's more money. It's a $300 million cost cap. It was a joint project between the University of Arizona, JPL, Ball Aerospace, and then a range of institutions from our science team. This was submitted in 2021. We were rated as Category 1 with no major weaknesses, but there were 5 missions that were Category 1, so we were not selected, which was really a heartbreaking experience. The mission itself is a long slit far UV spectrograph, so it was covering 135 to 165 nanometers at a very high resolution of 50,000 in the high resolution mode, and then it had a lower resolution mode of a resolution of 10,000 with a high Earth orbit similar to TESS. And we were looking at 3 different science objectives, all of which were observing fluorescent emission from molecular hydrogen, which is the most abundant molecule in the universe. It's typically not observed, but it actually has a really rich and abundant emission, fluorescent spectrum in the ultraviolet. So this would have been the first mission designed to actually observe that in a systematic way in mostly nearby galactic molecular clouds. And we were looking at kind of 3 different topics that are in the 3 boxes here: formation, feedback, and disk dispersal. So trying to understand the link between molecular cloud formation and destruction and how that connects with stars forming, how UV bright stars actually destroy the molecular clouds that they're formed in. And then the primary component of planet forming disks is actually also H2. And so we were looking at the same tracers kind of apply in this very different situation of planet forming disks and how they get dispersed over what timelines. So this was not selected, which was a real bummer, but I decided, well, I'm just going to keep trying. And so I'm reformulating the same science concepts, but with a different name, and for the lower cost cap for the small Explorer, which was supposed to be due in 2024, roughly a year from now. And then a couple months ago, it was pushed back to 2025 because of some issues with the astrophysics budget. So this is a challenge because the cost cap is significantly lower. It's 175 million instead of 300 million. So we basically have to cut everything in half. So the instrument capability is going to be reduced. We'll have a smaller primary mirror. The Hyperion primary mirror was 48 centimeters. This one will be smaller, lower spectral resolution, and maybe fewer or limited science objectives. And so for branding purposes, because you're trying to shrink something, it makes sense to change the name, even though I love the name Hyperion. And so we're going to call it Eos. In Greek mythology, Eos is the daughter of Hyperion, and she is the goddess of the dawn. In the Roman mythology, she's called Aurora. And Hyperion has 2 other children, the sun and the moon. And I felt like, well, that's not appropriate for an astrophysics mission. So Eos will be the dawn. And it turns out, and also this is like some of these graphics, this is an ancient Greek pod, and she's the one with the wings, is Eos. And it actually turns out that some of our science objectives we can port over directly from Hyperion. The first one, science objective 1, determine to what extent molecular clouds formation and destruction regulate star formation. We can do that with just the spectral resolution of 10,000 and with a smaller mirror because it's a diffuse object. And then we have 2 other objectives that are focused on how UV bright stars disperse the molecular clouds and also change the photochemistry that may be happening in these cloud regions. And then we're still trying to figure out what to do about if we can make some observations that would be helpful for the planetary people, for planet formation, exoplanet people. So trying to figure out maybe short-term variability of stars with planet-forming disks and how that might drive the dispersal of those disks. So we have a rough optical design. The top figure is the spectrograph, and then the bottom figure is the telescope design. So this is going to be, it's actually inspired by SphereX for the telescope. It's a 3 telescope or 3 mirror telescope assembly, and it's off axis. So we're still working with JPL. We're doing a costing exercise actually next Wednesday. So that's the kind of the first step to decide if we're going to keep going, is to see how much this redesigned version might cost. And then we'll start moving forward. And if the timeline stays as we're hoping, we would go through a gate review with JPL in 2024. The submission would now be in mid 2025, and then we would find out about selections in 2026. So as all of these space missions, there's always a really long timeline here, but we'll see what happens. And I'm happy to take any questions. Thank you.
Actually, I don't have a question. I want to compliment you as a space reporter. I applaud you for not using silly acronyms in your name, but actually finding real content.
I hate the acronyms.
The acronyms that are so fake.
Yeah.
It just drives me crazy.
Yeah,
I really appreciate that.
Hyperion was not an acronym. It's like the name of this Greek god, and since he's the parent of a star, I wanted like and it's also a really good poem and a very weird and interesting series of sci-fi books. But yeah, I hate the acronyms. They're the worst. Sorry, everybody, but they're bad.
A lot of the acronyms, they could just drop the acronym and just use the word.
Yeah,
why do they
like
even
it's
wait?
fine to name your instrument Sauron. Just go with it.
Yeah, that's right.
Thanks.
NASA is fine. I'll allow it.
How have you gone about retrenching, descoping the science elements of your mission? What's your philosophy behind that? Have you gone from an exhaustive survey to a more exploratory? What's your...
So my feeling for descoping was you have to kill your darlings. You can't love any of it too much. And so we kind of reflected on what was driving a lot of the design choices for Hyperion, and the resolution of 50,000 was what was doing it. So that was the first obvious thing, to just axe the resolution, the high resolution mode. It's just a resolution of 10,000. What can we do? And we had to, the disk dispersal required very precise measurements of the wind velocity coming off of the H2 disk. So with a resolution of 10,000, we can only do 5 to 10 kilometers a second. So we had to axe the disk dispersal in that form. And but the part of the reason why we had that was because we wanted to bring the exoplanet people, or have them feel like they were going to get something out of this mission. So we knew we can't do exactly that. We have to figure out a way to make it work with a resolution of 10,000. And then the other stuff actually turned out to be easier because it's mostly diffuse sources, and for diffuse sources that fill the slit, you can make a smaller telescope size, and depending on the other choices that you make for the instrument, you don't actually lose any sensitivity. So for the other two, we didn't really have to change that much, and it's more of we get rid of the high resolution mode, which gets rid of the very precise velocity measurements, and then making adjustments for that. And then also right now our strategy is to see what's the smallest mirror that we can get away with for the aperture. And then if we have some headroom in the cost, we can make it bigger, or we can just say we're really well, our budget is really good and we have a lot of reserves. So mostly, and even killing the name, I feel like you just can't be precious about it. You have to be willing to do what it takes, as long as you have some basic minimum amount of science that people care about. If it was axing everything, then there's no point in doing it.
Thanks.
I have a question. So assuming that this gets picked, because it's based on a Category 1 mission, it's going to be Category 1 again, of course. What would happen here? Yeah.
So yeah, it better be picked if it's Category 1, or I'm going to burn that building down. So what would happen here is, first we would be the center of the science team. A huge fraction of the science team is actually already located here. And in the original conception for Hyperion, we had Ball doing the mission operations. And now that we have the mission operations center at the ARB, I think we're going to totally cut that out and just have all the mission operations be here from the beginning. And so there would be like the science center and the mission center. All the operations would happen here. Yeah, it would definitely save money. Everything is cheaper here than certainly at Ball Aerospace. Thank you so much.